Hello and welcome to today's lesson, a review of inference procedures for AP free response questions. And the hardest part when you get to the AP exam is determining what type and knowing that it can be any possible category as a part of the question that's given to you. So when we look at our first step, we have to determine what type of test is it. So when we're looking at the situation, we always want to look at the question itself. And the good news is, if it's a confidence interval, you're going to be told that it's a confidence interval. Okay, so know that if in doubt, you would always do a hypothesis test. Okay, only do a confidence interval if that's given to you. Now, in this confidence interval problem, we can see that we're given fractional values. 188 of 200, 180 of 200. Okay, so that's really telling you, and also look at the question itself. The question is telling you that it's a proportional problem. So in this situation, we've got a two-sample proportional confidence interval. Okay, and that's always important to define what are you doing. Everything else is built upon those pieces. Now, if we look at this second question from the 2006 exam, what we have is we have a data table. Okay, anytime you have a data table, you know that you're going to be dealing with a mean value problem. So what you have to do is, if you're given the table, you got to plug this into your calculator, find your mean value and your standard deviation. Okay, and if you don't remember where to go there, we want to go into our stat, edit, okay, type in our data values, and then we would go back to stat, calculate to do our one variable statistics, or in this case, two variable, based on the situation. Now, when you're dealing with mean value problems, one samples are pretty easy, but when you get to a two sample, what you really have to look at in a two sample problem is how many groups are being experimented on. And in this situation, this is just one group with two values. Okay, so this is the big key to do a matched pairs. So this is a matched pairs situation, and what we have to do is we have to find the difference of all of these values, and this actually turns into a one sample problem once we find all of the difference values here. Okay, now, worst case scenario. I know some of my students worry about, matched pairs. Am I going to do it right? Worst case scenario, you do a matched pairs as a two sample problem. You will lose a small amount of credit. Okay, you can't get a full 4 on it. Okay, but you can easily get a 3 if you do this as a two sample problem correctly. And that's why it's important to name what you're doing. Like I said, best case scenario here, it's matched pairs. Okay, so we're looking at that. Also notice in the problem, it's telling you the type. Okay, we've got a mean value problem, so we need a mean and a standard deviation for this problem. So we need a mu of x. We need not a sigma x. Okay, we need an s of x value for this situation. Okay, so that's the important part. When you're defining what you're looking at, you're pulling out those values, and it's really starting you on the road of what type of problem you're working with. Okay, now, there are 4 parts to any test, and you want to make sure these are the pieces that the AP reader is looking for, the scoring guide is asking you for. Number 1 is the type of test, and your null and alternative hypotheses. Okay, now remember, in this situation, context is vital. Okay, so make sure that you're always putting context in whether you're defining your values or working from there. So we've got our type of test, our null and alternative. Now your null and alternative can be based off of a mu value of x. Okay, it can be based off of a proportional value. Okay, remember your null is always the equal to, your alternative is always your less than, greater than, not equal to in those situations. Okay, so you need your type of test and your null and alternative. This is going to come from the wording of the problem. You know, is it greater than? Is it less than? Is it not equal to? You know, look for that wording that's going to tell you the symbol to use there in the type of test. Number two, okay, you need to verify your assumptions or conditions. You know, it can be called different pieces for each, but these are the two main terms for that. Okay, so we verify our assumptions and conditions. Part 3, you have to show your calculation work, even if you're letting your calculator find the values for you. Okay, you have to make sure that you show the reader that you can use the calculation formulas. And then the last piece is the conclusion. Okay, and when we get further on into this lesson, we'll talk about what are the main parts of these. But we just want to say, as soon as we know it's a test, we have to lock in and say we need these 4 pieces. Okay, 4 parts to an interval. Okay, the first part of the interval is a really small part. Number 1, it's the type of interval and your context. Okay, what is the variable that you're looking at here? You know, so it's p equals mu of x equals, just defining that variable. Okay, so what type of interval are you doing? 1 sample, 2 sample, mean value, proportional. Okay, you have to name those pieces. And after we've done that, what is the second part to your interval? Assumptions. Okay, going through, verifying your assumptions, conditions. What's the third part to an interval? Calculations. Okay, just like with the test. And what's the fourth part to an interval? Your conclusion. Okay, so we're looking for those same pieces every time. The only thing that's a little bit different is an interval doesn't have the null and alternative hypothesis. So all we need there is that's where we're going to put in the context that we use later in the question. Okay, now assumptions. When we're looking at assumptions, we have to verify 3 things. Is it random? Is it independent? And is it a normal sample distribution? Now, the first 2 they are not dependent on type. Okay, random and independent is something that we do the same way in any test or interval. Okay, so for random, we're just looking for the statement in the question. You want to look for the statement in the question and copy it. Random sample of 15 people stated in problem. A simple random sample of 200 individuals stated in problem. Look for the statement and copy it when we're talking about the random nature. Okay, you have to verify that. Okay, when we look at independence, there can be 2 types of independence. You have your individual sample. So when we look at each sample size, little n, times 10, is that less than the population? Okay, so these are for our individual samples. Okay, so is the individual sample small enough to be independent? Okay, that's part 1. And then if it is 2 variable, you have to say that those variables are independent of each other. Okay, and that should also be stated in the question. Okay, so you want to find that piece that talks about the two samples being independent of each other, or when you're looking at the situation, if it's night shift, day shift, the two shifts are independent of each other. One shift doesn't affect the other shift overall. Okay, so we have our random assumption, we have our independent assumption. Okay, so those are nice that they are the same no matter what type you're dealing with. The one that is always the most difficult is when we're talking about the normal sampling distribution. Okay, we need to know that our sampling distribution is normal, so we can use the T or Z test for that. And these are different between mean value problems and proportional problems. Now, if we're dealing with a proportional problem, that is our best case scenario because it is one thing that we test. We're testing our sample size times our proportional value, and we just make sure that that's greater than or equal to 10. The same thing with our sample size times 1 minus our proportional value greater than or equal to 10. And you have to do these two calculations for each sample. So if it's a 2-sample problem, you should have 4 calculations. Okay, so we're doing those calculations for each in a proportional problem, and then once you've done that, you can say, based on this, we know that we have a normal sampling distribution. Now, in a mean value problem, it can be one of 3 things. Best case scenario, you can be told, and if you are told, you got to copy it. Okay, anytime you're given information in the problem, you got to copy it into your answer. So you can be told that it is a normally distributed data. Okay, the next best thing is large sample size. Okay, and that is n greater than 30. Okay, if our sample size is greater than 30, then we know based on this large sample size that we have a normal sampling distribution. Okay, worst case scenario, you have to graph it. And in this case, they have to give you the data. Okay, we're looking at a box and whisker. Okay, and you want to graph a box and whisker plot, okay, using the 1 variable data to put it in there. If it's a 2 variable data, you'd have to do both of your box and whisker plots. And what we're looking for here is no outliers and no extreme skew. You know, and when we're talking about extreme skew, you know, we're looking at a box and whisker that would look something like this. And this might even have a couple outliers. You know, so extreme skew means that it's almost an outlier, you know, just not quite. Okay, so that's the hard part. If it's a mean value problem, you got to do a little bit more to prove that you have a normal sampling distribution. Remember, put that statement in when you finished verifying that assumption. Okay, proportional problems for each sample, you just run this calculation and it takes care of itself. Now, the next piece is your calculations. Like I said before, the calculator can do everything for you, but you have to show that you can use the 2 formulas and plug in the values, even if you use the calculator to get the final answer. Okay, so if you're doing a standardized test statistic, okay, this shows you what you need to build your T or Z. Okay, so that's the name for that T or Z. It's a standardized test statistic. Okay, and then when we're looking at the formula, you know, you have your X value or your P hat, and then it's minus, and this comes right from your null hypothesis is your parameter value. Standard deviation comes from below. You have to make sure you're picking the right type and then putting in the values appropriately. Okay, for your confidence interval, we need our statistic. We need the critical value, which comes from your T table. Remember, you got to be used to and comfortable with that t-table, and I'll show that here in a little bit. And then the standard deviation overall. Okay, so this is all off of the formula sheet. They don't ask you to memorize this. You just have to be able to look through and use. So once again, based on what you named, is it a single sample mean value? Is it a single sample proportion? Okay, then you're picking your formula, and then you would build your t-value if it's a mean value situation. So x minus whatever your HO is, in most cases that's a 0. Okay, and then you would plug in your S of x over square root of n. And now you've built t. If it's a proportional problem, z equals p hat minus your HO value, and then we would plug in p from the HO into this formula to finish your z value. No different if it's a two-sample problem. Okay, well, if it's two-sample problem, is it a difference of means? Is it a difference of proportions? One thing I'll tell you to do, just cross out this formula right away. If it's a mean value problem, always use this one for your standard deviation. And we can work from there. If it's a proportional problem, this is where we really have to be careful based on type of formula. This first formula is for your confidence interval. The second formula is for your hypothesis test. Okay, and the good part is it is listed alphabetically, and if you know, the hard part is the formulas are backwards up here. You know, so they're doing a few things not to make it too easy for you. Okay, you just have to remember that, look at this special case. What does that special case look like to you? It looks like a hypothesis test statement. So that's why it's telling you to use this formula. And then from here, we would build our t, build our z, you know, build the confidence interval. So if I'm building a t value, you know, it's x1 minus x2 over, and then we drop in that standard deviation formula. You know, if we're doing a proportional test, our z value equals P1 minus P2. We're always dealing with a difference value. And then we would drop in our standard deviation formula underneath there to finish that z value. Now, once you have your t or z, then you need a probability statement. What is the probability of t greater than, less than, not two greater than? So let's try this again. It's Monday morning, it's always tough. Your value equals, and then you plug in that entry. You know, if it's a z test, what's the probability of z being greater than, less than that number, and what it equals. Okay, so there's not a lot you have to show for calculations. Like I said, the calculator can actually do the work for you. You just got to make sure that you're showing these values as a part of your work. And now when we look at the calculator, where would you go for these? If you're just doing a straight z value, t value, you would use your normal CDF for doing a z value, lower boundary, upper boundary. Don't change mean and standard deviation. If you're doing a t situation, we would use the t CDF, lower boundary, upper boundary. Whoop. Let's get out of here, out of there. Let's try that again. Okay, and the nice part, especially if you have the new operating system, okay, it really helps you to remember some pieces with your TCDF. Degrees of freedom, sample size -1. If you have two samples, it's the smaller sample size -1. Okay, so that's the good part of that. Now, if you really wanted to go through everything, you can let the calculator do the test for you. Okay, we would just go over to our test. Is it a two sample Z, a two sample T? Nice part about the calculator is it really shows you everything you need for the calculations as you go through and find those values. Okay, but we want to make sure we list everything in the page. Okay, now wrapping up every problem. Okay, we wrap up the problems with a conclusion statement. If you're doing a test, you need 3 things for your conclusion. State your evidence based on our p-value of blank compared to our significance level of 0.05. Okay, what conclusion do you make about the null? Reject if your p-value is lower than the significance level. Fail to reject if it's higher than the significance level. And then the last part is a statement about your alternative in the context of the problem. This supports if you're rejecting the alternative, and it does not support if you fail to reject the alternative. Okay, if you have all 3 of those pieces, you're going to be guaranteed full credit for that conclusion statement of a hypothesis test. And then your interval conclusion needs 3 things. Your confidence level, we are blank percent confident, whatever it says in the problem. The interval you created, lower boundary, upper boundary, and then the context of the problem. Okay, usually I would actually put the context in as the second piece. We are 90% confident that the true mean value of PSI in the New England Patriots footballs during the AFC title game is between this number and this number. Okay, now, one thing we talked about real quick is when we're doing intervals, okay, to make sure that you know where to go for your specific values. Okay, and this is the one time where something given to you in the packet is so much easier than the calculator, and that is using your t-table for any confidence interval problem. Because notice, they put the confidence levels right at the bottom, and all you have to do is read up to your degrees of freedom. So if we want an 80% confidence interval for a Z problem, even though this is a t-table, we can actually match that up. Okay, if there's 40 degrees of freedom in a t problem for that same interval, okay, we have to make sure we match up that value. So always remember that this t-distribution table is a great, useful tool if you're given a confidence interval problem. Okay, and that is our quick review of hypothesis tests and confidence intervals for the AP exam. Thank you.